chromatography. Some of you may know some stuff. Some of you may know some things, and some of you may be thinking, I don't even know what that word means. So go ahead and just brainstorm for a minute while we let everyone else pop in, and we'll see what we can get for chromatography, paper chromatography more specifically. So if you know anything, go ahead and put it up there for me, please. Well, judging by the fact that nothing has gotten written yet, I'm going to guess that this is a new topic for everybody, which is awesome. It's always fun to review things, but great when you get to learn something completely new. Oh, I want to check my mic. Make sure that everybody can hear me. So if you could just answer the poll for me. Awesome. There's one person who's having a hard time hearing me, so I am going to have her log out and then log back in. And hopefully that will solve her problem. And while she is doing that, we are going to start thinking about chromatography. So if you look up on your PowerPoint screen, there's a sheet that says paper chromatography, and it has 3 different pictures. The first thing we're going to do is talk about what chromatography is. Now, it is a pretty fancy word, and it's a pretty fancy definition, but basically, chromatography is a technique for separating mixtures into their components in order to analyze, identify, purify, or quantify the mixture. So let's think of a solution. Let's say we have lemonade mix. In the lemonade mix, we have water, and then we have the sugars and the dyes. What we are going to do today is we are going to try to separate colors. Now, chromatography works really well when we are separating colors, as long as the color is in the form of a liquid. So we are going to make a liquid. Sometimes people use paints, sometimes people use Sharpie markers or other types of pens. We actually are going to use Skittles to make our solutions. So let's go ahead, and at the bottom of this screen it says mixture, which would be a color. So if you remember back to art class, step away from science for a minute. What colors make up the color green? Raise your hand. What colors make up the color green? Brianna, go. Oh, Brianna, go ahead.
Yellow and blue.
Awesome, yellow and blue. So if you have something green, a green marker, a green Skittle, there is part blue in that and part yellow in that. So when you are doing chromatography, you start with the green, and then it separates into the different components or the different parts. So it would separate into some yellow and some blue. And when you have these different colors separated, then you can do things with these colors. You can analyze things, identify things, purify things, or quantify things. Now this seems kind of abstract, like why would anyone need to use chromatography? Well, scientists use chromatography in 4 main ways. Would anyone like to read this slide for me so we can learn about how scientists use it? Shelby, you were first, go right ahead.
Analyze, examine a mixture, its components, and their relations to one another. Identify, determine the identity of a mixture or component passed on. Now, components, purify, separate components in order to isolate one of interest for further study. Quantify, that determine the amount of the mixture and are the components present the sample.
Okay, great job, Shelby. Chromatography is used by scientists to analyze, identify, purify, and quantify. Some real-life examples of how a scientist might use chromatography. A pharmaceutical company, so someone who is making medicine. They might use chromatography to determine the amount of each chemical found in a new product. That way they know how much of any given medicine to put into their medicine. A hospital. A hospital can use chromatography to detect blood or alcohol levels in a patient's bloodstream. Law enforcement, so police officers. They can compare samples found at a crime scene to samples from a suspect. An environmental agency. They can determine the level of pollutants in the water supply. Or a manufacturing plant can use chromatography to purify a chemical needed to make a product. All of these real-life examples of chromatography are done in a very stable, secured environment or lab. Not like your kitchen table where we are sitting today. Sometimes scientists can use water in their chromatography, which is what we will do today. Sometimes scientists use alcohol, like rubbing alcohol, or various other solvents. The only catchphrase or the only qualifier is that if you're using water, what you are trying to test needs to be water soluble. If you are using alcohol, whatever you are trying to test must be soluble in alcohol. So in chromatography, we did the definition already, and here's a little simpler definition. It separates the components of a mixture by their attraction to the mobile phase and the stationary phase. Well, that's great if you know what mobile phase and stationary phase are. So the compound, or whatever we are testing, today it's going to be Skittles, is placed on a stationary phase. The mobile phase, which is the water, passes through the stationary phase, which today is going to be our filter paper. The mobile phase carries the individual components, so the individual colors, a certain distance through the stationary phase, depending on their attraction to both phases. So that's a little bit confusing, but hopefully this picture is going to make it a little bit easier. On the left-hand side, you have your chromatography sheet. We are going to use a piece of filter paper today. You are going to put what we are testing on the filter paper. Then you are going to hold it in some water. Now, what do you think is going to happen? Maybe you've seen your parents make coffee before. Maybe you've used coffee filters in something before. But what if you take and you put the edge of a piece of coffee filter in water? What is going to happen to the coffee filter? Anyone know? If I take the edge of a piece of coffee filter and put it in water, anyone know? Xana, go right ahead.
It sucks up water.
Very good. So I'm going to show everybody. Here I have a dry coffee filter, and here I have a glass of water. What I'm going to do is take my dry edge, and I'm going to put it in the water. What is happening is the water is moving up the coffee filter. So now instead of just the bottom part being wet, the tip where I put it in, my coffee filter is wet. Maybe about an inch or two going up. All right, so I just shut my camera back off and hopefully I will unfreeze. So then what happens is if you had put a dot on your coffee filter and it was from a pen, some of the colors of that pen are going to move up the coffee filter, causing the separation, just like the picture on your PowerPoint screen. Different colors are going to move up different distances. So here is how we are going to set up today's lab. Just to give you a visualization, you're not actually doing it right now. You are going to take a coffee filter, you're going to make marks on it, and only the bottom portion is going to be placed in the water. So what we are going to do now is we are going to start our lab. Now, is there anyone, last week Elizabeth volunteered to be on camera. Is there anybody who would like to volunteer to do this lab on camera this week? All right, Shelby, if you would like to volunteer for half of it, and then Xana will switch to you. So Shelby, let me turn your camera on and turn mine off. And I see her coming. All right, so there's Shelby. So Shelby's going to do the lab live today. And the rest of us are going to kind of follow along and do it on our own if you have the materials, and if you don't, then that's fine. Okay, I can see you, Shelby, but I'm going to keep my microphone on. So, your lab today, you need a few things. Shelby has some of them up there in front of her. The first thing we are going to do is we are going to get our Skittles. Or M&Ms, whatever candy you are using. As long as it is a colored candy, that's fine. Now I want you to pick 4 different colors of candy. Whatever 4 colors you would like. And you need 1 of each of those candies. And put them on your piece of aluminum foil. Okay? And you can see Shelby's right in front of her. If you only have 3 colors, perfectly fine. If you only have 1, that's fine. You are going to take your toothpick. You are going to dump the toothpick just a little bit into water. And then you are going to put a little bit of the water on top of each of your Skittles. A couple drops on each Skittle. Use a new toothpick for each Skittle, M&M, candy, whatever you're doing. What you're trying to do is you're trying to get the dye to run off of your Skittle. So see how Shelby is just putting a couple dots on each Skittle. If you need to use your finger because that's easier, that is fine. And we're going to let it sit for a minute and kind of get the color to run off of our Skittles. Basically what you're doing is like if you get your hands wet and then you touch the Skittle, the dye comes off on your hands. That's what we're trying to do now. We're trying to get the dye off of these Skittles. And we're going to let it sit for just a minute while we get the dye good and runny. As we're waiting for the dye to kind of absorb off, what we are going to do is we are going to get your piece of coffee filter, and you are going to either tear it or cut it into a square. It does not have to be perfectly straight sides. It just needs to be skinny enough that it will fit inside of whatever cup you are using. Okay? You can tear it, you can cut it, make it into a square so that the square is skinny enough to fit into the cup you are going to use. So it looks like Shelby has a pretty big cup there, a measuring cup that she's going to use. So she doesn't need to make it really small. She just needs a square, or actually a rectangle, just like she has. And now take a look at your Skittles once you have your rectangle cut, and see if you can see some drops of dye underneath or above your Skittle. If you can, go ahead and click yes. Let me just send a poll. Okay, Ian and Xana, do you see any color around your candy?
Yes.
Awesome. Okay. Now we are going to set up our chromatography sheet. So we have our rectangle, our square, whatever color, whatever shape you have. You are going to take a ruler. If you don't have a ruler, you can estimate and measure from the bottom of your coffee filter about a ½ inch up. And with a pencil, you are going to draw a line across your coffee filter. It needs to be a pencil. You cannot use a pen. So if you don't have a pencil, please go get one. About a ½ inch up. Okay, I can see Shelby getting her ruler out and measuring. About a ½ inch up, you are going to draw a line with your pencil. Do not use a pen. And draw a line all the way across. This is the line we are going to make our dots on. You are going to take a clean toothpick, or the other end of the toothpick you used earlier. You are going to pick which M&M you are going to start with. So I'm going to start with my purple Skittle I'm using. I'm going to move my Skittle to the side so I can get some of that dye. I'm going to dip my toothpick in the dye, then touch my coffee filter with the tip of my toothpick and make a dot. I'm going to do this a couple times until I can actually see the color. So for example, if I have a purple Skittle, I want to make sure that I can see purple on my coffee filter. Then you are going to make an abbreviation for what color you did. So I used purple, so I'm going to, with my pencil, write a P right underneath my purple dot. Okay, and I'm turning my camera on for you as well, just so you can see this. So here I have my paper. I have a dot of purple. It doesn't have to be a pretty dot. And then I wrote the letter P. Okay, just like Shelby's been doing on her screen. Now I'm going to take my next color. So for me, that next color is green. And I'm going to, with a new toothpick, make a couple dots of green somewhere else on that line. And then I'm going to label it with a G for green. And if I have a third and a fourth color, I'm going to do the same thing for those colors as well. And now that I'm doing mine, I really only have room for 3 colors, so I'm only going to do 3 of my colors. Once you have all of your dots done, go ahead and either raise your hand or give me a little smiley face next to your name, just so I know all your dots are done. All right, Shelby, thank you so much for letting us watch you do the first part of the lab. You set the lab up for us perfectly. Now, while the rest of you are finishing your dots, I'm going to turn my camera back on, show you mine again. I have purple, green, but my dots are wet. Yours probably are too. We need these dots to dry out. So what I need you to do is take your little piece of filter paper, shake it around, blow on it. We need to get these dots to dry out. So go ahead and dry them out by flipping it, blowing on it, whatever works. As we're getting these to dry, we are going to try and make a conclusion or a hypothesis. My first two are pretty dry now. I'm just waiting on my red. So we need to make a hypothesis. So I told you that what happens when we do chromatography is the colors are going to separate. So let's think about the colors that you used. Now, everyone's hypothesis is going to be different because I used purple, green, and red. You might not have used purple, green, and red. It looked like Shelby used white, red, and blue. Okay, so you're going to look at your colors. And you are going to say, on the beginning of class we said that green is made up of blue and yellow. So if I use a green color, I'm going to guess that I'm going to get some yellow out of it and some blue. So what I want you to do is on a scrap sheet of paper, write your hypothesis. I'm going to write mine up on the whiteboard. So if you want to click on your whiteboard so you can see mine, you certainly may. So here I have Mrs. Berg's hypothesis. Brianna, do you have a question?
Like to write it on the board too?
If you want to write it on the whiteboard, you certainly can. If you want to write it on a scrap sheet of paper, that's fine too, whatever you want to do. So my hypothesis is going to be that my purple dot is going to have red and blue. My red dot will have, I think, just red. And my green dot will have blue and yellow. So you're going to make your hypothesis. Remember, your hypothesis can't be wrong as long as you are making an educated guess. So I'm going to give you a few minutes to make your hypothesis. When you are done, click yes for me. Okay, just jot your hypothesis down either on the whiteboard or on a sheet of paper. Whatever is easiest for you. Okay, you should have your hypothesis done now. And I'm hoping that your dots are dry. If your dots aren't dry, take a minute to blow on them. And Xana, you had volunteered to show us the second half. Are you still interested?
Yes.
Awesome. I just turned your camera on, so go ahead and click. And the same thing, I'm going to leave my microphone on so I can walk you through it, and we will watch you. So you have your paper with your dots, and then you have some sort of container that you're going to put water in. It looks like Xana has a measuring cup right in front of her. So what you're going to do is you're going to pour just a little bit of water into that measuring cup, about 1/4 inch. Whatever you do, you need to make sure that you have less water than where your line and dots of color are. You don't want the color to actually hit the water. Okay, then, oh, and I can see Xana's paper. Don't put it in yet. Just hold on. Not yet. What you're going to do is you're going to take either a pencil or a toothpick or your ruler, something, and put it over your cup with the little bit of water in it. Kind of like a bridge. Okay, and I'm going to just turn mine on for a second and tilt. See, I have my ruler over my cup. Then you are going to take your chromatography paper and you're going to tape it to the ruler so that the paper is just touching the water. And we are going to see what happens. Okay, so let's watch Xana as she does hers. We're trying to just have it touching the water. And we're going to let this sit here for a couple of minutes. Hopefully, what you are going to get is something that looks like the picture I am about to put on the whiteboard. Hopefully, you will get something like this. Now, on the whiteboard, there's a lot more colors. But hopefully, you'll get different colors that come out of your one dot. So we need to let this sit on the side. So we cannot do anything else with it right now. We'll come back to you, Xana, in a couple of minutes and check on yours. And while we're waiting for our water to move up the coffee filter and hopefully take some of the colors with it, we are going to talk about 4 different types of chromatography. These are up on your whiteboard screen. The first type of chromatography is liquid chromatography. And that's what we're doing right now. We are separating a liquid sample, which we turned our dye off of our Skittles or M&Ms into a liquid using water. And we are going to separate the liquid sample with a liquid solvent. Our liquid solvent was water. The second type of chromatography is a little bit more complicated, and it's called gas chromatography. Now, gas chromatography is not something that you could do at home, unless you have a fancy-dancy science lab in your basement. Gas chromatography separates vaporized samples, so it separates gases, and a column composed of liquid or solid beads. And I'm going to show you pictures of all of these in a second. Next is paper chromatography. Paper chromatography separates a dried liquid sample with a liquid solvent, which is actually more along the lines of what we did because we are hoping that your liquid M&Ms were dried. And the last type is thin layer chromatography. Thin layer chromatography separates dried liquid samples with a liquid solvent in a glass plate covered with a special type of alumina or silica gel. And that's a little confusing, not being able to see what you're talking about. So we are going to see what hopefully is going to happen with our M&Ms, except with a Sharpie. So if you take a look at that screen, it says, what color is that Sharpie? And you have paper chromatography of 4 different colored Sharpies. Now they did this lab with Sharpies rather than with Skittles. And the reason I did it with Skittles is because Skittles are water-based, so we only had to use water. They had to use alcohol. So they did the same thing. Xana, you have a question?
We cannot see anything on the whiteboard.
You can't find the whiteboard.
We can find the whiteboard. We cannot just see what's on the whiteboard.
Oh, we're looking at the PowerPoint screen, so the top right one. Are you able to see that one?
No, I do not see the PowerPoint screen.
Okay, I hit refresh on my end. Why don't you hit the refresh button on your browser or log out and log back in? And hopefully you'll be able to see it then. Go ahead.
We see it now.
Awesome. Okay, so this picture is of Sharpies. Now, when they did this, they had a purple Sharpie, a blue Sharpie, a green Sharpie, and a red Sharpie. If you look at the purple Sharpie, The stripe going up all the way was purple. If you look at the blue Sharpie, it was blue all the way up. The green Sharpie, it was green. And the red Sharpie appears to have a little bit of orange in it. So what this is telling us is that when Sharpie made their dies, it was all one consistent color when they mixed it all together. What should happen to ours, at least with the Skittles, is we should get some good separation between the colors. And as we let things sit, you will get more and more difference between the colors. So at this page right now, you see at 0 minutes what was happening to the Sharpies. And if you follow the pictures all the way along and you get to 30 minutes, you see that the colors moved farther and farther up the sheet of chromatography paper. Our chromatography papers have been in for about, mine has been in for about 4.5 minutes. We are going to let them go to about 5 minutes, and then we are going to pull them out. So what I would like you guys to do is take your chromatography out of the container. Don't hold it over your computer because it's going to be wet. And you should be able to tell what part of your coffee filter is wet and what part of your coffee filter is dry. Take your pencil and try to trace that line. You're going to have to go just above it so you don't rip your chromatography paper. So here is where my line is. You need to do it in pencil. I'll try to darken mine a little bit for you, but it needs to be done in pencil. It may not be a straight line. It may be a straight line. Okay, so I just went and darkened mine for you. And this is what mine looks like right now. You're going to take this paper and put it to the side. Take it, put it on the edge of your desk, on the edge of your table, and we're going to come back to it in about 10 minutes at the end of class. Anyone have any questions about what we just did in the lab? All right, fantastic. No more questions. Okay, well, what I want to do for a minute is I want to look at the whiteboard. And this is week 7 of our class. So we have 2 more weeks of this class. So I want to know what you are interested in learning about for our last week of kitchen chemistry. I want to know what topic you are interested in. Okay, it can be a simple topic like why do leaves change color? Or it can be a more complex topic, like why do fireworks work? I really want our last class to be a fun class. You guys are going to do a little presentation that I'm going to talk about in 1 second. And then I want you to come up with some topics. So I'm going to start brainstorming up here and give you some ideas of topics that we have done at the end of classes previous years. So one would be changes in leaf color. We've done fireworks before, why fireworks work. We have talked about the chemistry in our blood. We have talked about why eggs become hard-boiled. Give me some topics that you're curious about up on the whiteboard, please. Volcanoes? No one else has any ideas? No other ideas? Oh, volcano. I see 2 volcanoes. No other ideas? We certainly can do a baking soda and vinegar volcano. That is definitely something that I can do and you can do. Anyone else have another one? No? All right, well, I guess our last class, we will be concentrating on making volcanoes and why volcanoes work. So for our last class, then, you should have some baking soda and some vinegar, and maybe a few other supplies. I will look into some fun things we can do and let you know next week. Also on the last day, oh, go ahead, Shelby.
Why do we have
I'm sorry, Shelby, you got cut off. I didn't hear your whole question. I just heard, why do we?
we have salt?
We're going to add the salt at the very end. Okay, so just right now your paper is sitting to the side, and you'll see why we have salt in a second. Okay, we are definitely getting back to that, but it needs to sit for a minute. So, our last class, you guys are going to do a patient. 5 minutes at the most, nothing super fancy, but I want to tell you about it now so you can start thinking of some ideas. You are going to pick any science topic that you are interested in. Anything whatsoever. Then you are going to come up with a presentation. And I'm going to give you some questions to answer. So let's say, for example, the topic that you choose is fireworks. You are going to explain to us what fireworks has to do with science. And you are going to explain to us why science works, or why fireworks work in terms of science. So be thinking about what you could do for that last class. Now, let's look back at our chromatography paper. If I look at my chromatography paper and I bring it up real close here, you can see that my red moved just a little bit, but none of my other colors really moved. Raise your hand if your colors moved up your chromatography paper. My guess is most of them look like mine. So now what we are going to do is add our secret ingredient. Our secret ingredient is the salt. I want you to take a pinch of salt, just a little bit, and add it to your water. Mix it up. Then we are going to take our paper and put it back in. And hopefully this time we will get the colors to move. Sometimes they move with the salt or without the salt. Sometimes they need the addition of the salt in there to move up the paper. So we're going to let this sit for another minute in hopes that it starts to move. So once you have added your salt and your paper is back in, go ahead and click yes. All right, fantastic. So just keep an eye on that paper, and you want to try to let it get wet to about where your line was from last time. So about to where that top pencil mark is. So you're going to have to keep an eye on it and see what happens. Does anyone notice anything different going on in their chromatography sheet now that the salt is added? And then raise your hand if you notice anything different. Shelby, what seems to be happening in your paper?
When we started, my thing didn't move up, and now my blue and red are moving up.
Can I turn my camera on and can you, or not mine, can I turn your camera on so we can all see what's happening now? It's a little hard for us to see. Oh, I can see it a little now that it's picked up. But yes, they are moving up now, and that is fantastic. That's because of the addition of the salt. You either raise your hand or give me a smile face if yours is doing the same. Awesome. Zana and Ian, yours are doing the same thing. That is great. So what you are going to do is you're going to let this sit until it reaches about the same pencil mark that it did before. If that is done, take it out. If it's still working on it when class is over, you're going to just take it out once it reaches that mark. Then you are going to let your chromatography sheet dry. Once your chromatography sheet is dry, you are going to look at the colors. See what colors came out of which dots. Then you are going to write a lab report. If you think way back to like week 1, week 2, we wrote a couple of lab reports. I want you to write a lab report on this lab. You have your hypothesis written on a scrap piece of paper, and your conclusion is going to be, for example, my red dye separated into the colors blank, blank, blank. Or, my red dye did not separate into any colors. Your procedure is what we did, and your materials you can list. Does anyone have any questions about your homework? And then you're going to try to come up with your topic. And next week in the beginning of class, I'm going to ask everybody to share their topics with us. So anyone have any questions about the homework assignment? Go ahead, Brianna.
Is it going to be posted on Moodle or something?
Yep, the homework assignment is up in Moodle already. And I didn't write the chemistry topic up there. I just want you guys to be thinking about it, and you can share your topic at the beginning of class next week. But the lab is posted up on Moodle already. So has anyone made it up to the same mark or pencil mark, and they would like to share with us by turning their camera on? Mine has not made it up yet. Anyone else has made it up? Xana, let me turn your camera on and go right ahead.
It came up to my line a little bit higher.
All right, very good. Anyone else have their paper up to their line? You can pull it out of the water. It makes it a little easier to see. It's taking longer to get to that line this time because there's salt mixed in the water. So I would expect it to take a little bit longer to get up to that point. Go ahead, Brianna.
I don't see my colors at all. They pretty much just disappeared. I don't know what.
All right, well, if your colors just disappeared, then there's not much you can do about it. You can try to do the lab over if you would like. Or in your conclusion would be the colors disappeared, so I could not tell what came out of my original dots. And sometimes when you're doing a lab, something somewhere goes wrong, and that happens. Nothing to worry about. Shelby, go ahead.
Mine to the line. And Harry took it out. Yeah.
Okay, I turned your camera on. Do you want to share it? Shelby? Maybe? All right, well, on that note, we are at the end of class. I hope that you guys have a great weekend. I will see you on Monday. Your lab reports are not due until next Friday, so you have a full week to work on them, but try to come up with that topic that you're going to do your presentation on by Monday. I hope you guys have a great week and enjoy your weekend.